All right. Trig lecture 3233, the student will review the use of the law of sines and the law of cosines as applied to oblique triangles. Oblique triangles are triangles that are not 90-degree triangles. They're not right triangles. So a quick review of the law of sines. A is to the sine of A, as B is to the sine of B, as C is to the sine of C. And we can set up a proportion, two ratios set equal to each other, by just taking any two of these and setting them in equal to each other. I can say this is equal to this, or these two are equal to each other, or this is equal to this. That's what it means when we set them all equal to each other. So I'm going to try to use the law of sines to solve these two and move onward through the following. This is round to the nearest tenth. So what am I looking for? Looking for AB. Remember when two letters are written right next to each other without a symbol above them in geometry? That meant the length of line segment AB. That's what it means here. The length of AB, I'm going to call C, little c, because it's opposite angle C. And I'm going to use my law of sines if I can. C is to the sine of 52 as 20 is to the sine of 61. I can use the law of sines, so I'm going to. Here we go. Say C is to the sine of 52 degrees as 20 is to the sine of 61 degrees. Kind of sloppy. Okay, so there's our equation. We have one variable. I'm just going to, I could cross multiply, but it's quicker just to multiply both sides by the sine of 52. This is C divided by the sine of 52 degrees. So I'm just going to multiply both sides by the sine of 52 degrees. And that will isolate C. Scooch this over just a little bit. When I multiply this side by the sine of 52, remember, you can think of the sine of 52 as the sine of 52 over 1. That would cancel these. Times the sine of 52, you can think of it as over 1. And that will give me C on this side of the equation is equal to 20 sine 52 degrees over sine 61 degrees times 1, which is sine 61 degrees. Now I just want to get this into my calculator and round it to the nearest tenth. So that's what I'm going to do, if I can find my calculator. It's around here somewhere. No, it's way over there. Let me go get it. Hi there. Okay. 20 sine 52 equals divided by sine 61 equals, I get 18.0 rounded to the nearest tenth. I'm going to say that's approximately, that's my symbol, 18.0, and let's see if there's a unit of measure in the original problem. There is, so we're going to label our answer as inches. Okay. There we go. We used the law of sines and we found the length of side C, which they called line segment AB. The length of line segment AB, I called it C because it's quicker in using the law of sines. Okay. Here we go. Here I'm looking for, I found the length of a side here. Here I'm looking for the measure of an angle. So let's see if I can use the law of sines. I can say, I'm looking for this. I can say 29 is to the sine of C, as 33 is to the sine of 105. So that's good. I only have one unknown, so I can use that. I'm going to get rid of this. Give myself a little extra room. And I'll say that 29 is to the sine of C. As 33 is to the sine of 105 degrees. Law of sines. I'm going to cross multiply. That gives me 29 times the sine of 105 degrees equals, now I'm going to multiply these two together, 33 times the sine of C. Okay. So I cross multiply it, and I have this. I'm looking for angle C. So here's what I'm thinking. I'm going to get rid of this 33 by dividing both sides by 33. That's a multiplied 33. That will isolate sine C. And then, once I've isolated the sine of C, I'll find C by taking the inverse sine of both sides. So here we go. Let's see if I can do that without goobering it up. I'm going to divide this side by 33, 29, sine 105. Boy, that's very sloppy. Over 33 is what I'll have on this side of the equation. If I divide both sides by 33, on this side I'll have the sine of C. So what I'm going to do is find this value and then take the inverse sine of it. I'm going to take the inverse sine of both sides. And that will give me the measure of angle C. If I take the inverse sine of this, I'm just left with C. If I take the inverse sine of this, I'll get some value that will be the measure of angle C, and I'm going to round that to the nearest tenth. Hopefully I won't make a mistake. So here we go. 905 divided by 33 equals, now I'm going to take the inverse sine of that. I get 58.1. Rounded to the nearest tenth. And I'm labeling it degrees, and then I'm going to hope that's right. So easy. Hey, it's right. It's so easy to hit the wrong button and make a mistake. But yay, I've got 2 in a row. I haven't made a mistake. I don't believe it. That's a record. So we use the law of sines to find a missing side. We use the law of sines to find a missing angle. We have to take the inverse sine of both sides to isolate the angle. Okay. Let's take a look at this. Here's the law of cosines. There are 3 possible laws of cosines. I always just think of this one, and then from this I can derive these 2 really easily. A squared is equal to b squared plus c squared minus 2bc cosine A. So once I have that, I can derive these 2 really easily. And here we go. We're going to use the law of cosines probably. I always check when it says to find a missing side or angle in a triangle. I always check to see if I can use the law of sines first, because if I can, it's quicker than using the law of cosines. But if I can't use the law of sines, then I jump over to the law of cosines. So I'm asked to find AC. That's the length of line segment AC, which I'm going to call B, small b. And I'm going to look at this and say, can I use the law of sines? B is to the sine of 102, as 22 is the sine of, I don't know what that angle is, or 28 is to the sine of, and I don't know this angle, so I can't use the law of sines. So I have to use the law of cosines, and that's what I'm going to do. Here's what I'm going to be doing. B squared is equal to A squared plus C squared minus 2AC, cosine B. And I'm going to try not to mess it up. Here we go. B squared, don't know what B squared is equal to A squared, that's 22 squared, plus C squared, that's 28 squared, minus 2 times 22 times 28, that's 2 times A times C, 2 times A times C, times the cosine of B. What is B? 102 degrees. Now, if I can get all this into the calculator, that will give me B squared. I don't want B squared, I want B, but that's a start. Because once I know B squared, I can just take the square root of it, and I'll know what B is. So here we go. 22, let me clear my calculator, make sure. 22 squared plus 28 squared minus 2 times 22 times 28 cosine 102 equals. I get 1524. I'll go ahead and write it out. This is what's displayed on my display on my calculator. 1524, 1524.147,203, and it leaves my screen and it goes on forever. I want the square root of this, so I just take the square root of it. 39.0, rounded to the nearest tenth. So I'm going to say B is approximately 39.0, and look to see if I have any units of measure, meters. And then I just hope I haven't made a mistake. Okay, let's see here. 39.0 meters, yay! Okay, so that's 3 in a row I haven't made a mistake on. I can't believe it. Here's the last one. Find the measure of angle C. So let's look at this. I want the measure of this angle. Let's see if we can use the law of sines real quick. 14 is to the sine of C. As 6.3 is to the sine of, nope, I don't know that angle. Or as 15.5 is, nope, I don't know that angle. So I have to use the law of cosines. So I'm going to. Here we go. I'm going to erase this part right here, just to give myself a little bit of working room. And I'm going to use the law of cosines. What am I looking for? The measure of angle C. So I'm going to say C squared is equal to A squared plus B squared minus 2AB cosine C. We could isolate this first and then plug in all the values, or we could plug in all our values into this and then isolate C. That's what I'm going to go ahead and do. I'll try not to mess it up, but if you solved this for C before, you know, in variable terms, and then plug your values in, you'll get the same answer. Okay. So here we go. Oops, I don't want to scooch so far that I can't see my values. C squared is 14 squared, and try really hard not to mess this up, is equal to A squared, that's 15.5 squared, plus B squared, that is 6.3 squared, minus 2 times A, which is 15.5, times B, which is 6.3, times the cosine of C. Let's make sure I haven't messed that up. I've got C squared, 14 squared, is equal to A squared, 15.5, plus B squared, 6.3, minus 2 times A times C. I did mess that up. That should be a 14 if I'm not mistaken. Let me check that out again. I'm glad I double checked this. And let me make sure I'm not making a mistake again. Looking for C. So I got C squared is equal to A squared plus B squared minus 2 times A times B. Oh, that is 6.3. Golly. Cosine C. I had it right the first time, then I talked myself out of it. Okay, so I'm pretty sure that's right. So now I'll just try to get it in the calculator and not mess it up. So here's what I'm going to do. I'm going to subtract this and subtract this from both sides. And then this whole mess here is divided, I'm sorry, is times cosine C. So I'm going to divide by this whole mess. So I'm going to do that like this. This side is the left side of the equal sign. I'm going to subtract 15.5 squared from both sides. It'll show up over here. I'm going to subtract this from both sides. So it'll show up over here with the 14 squared. It's disappeared on this side. And then I'm going to divide both sides by this quantity, right? By this product. -2, -2. I'm dividing by -2 times 15.5 times 6.3. And in order to make sure I don't mess it up, when I go to enter this into the calculator, I'm going to put both of those in parentheses. This will give me the cosine of C if I haven't made any mistakes plugging it in. I don't think I have. I double checked it, but we'll, it's easy to make a mistake. Let's see what we get. If I don't get it right, I'm going to cry. 14 squared minus 15.5 squared minus 6.3 squared, put that in parentheses, divided by -2 times 15.5 times 6.3. I close my parentheses, hit equal, and I get 0.429800307, and that goes off my screen, and this is equal to cosine of C. I don't want the cosine of C, I want C. So I'm going to take the inverse cosine of both sides, and this will give me the angle measurement of C if I haven't made a mistake. So here we go. The shift cosine equals 64.5 degrees rounded to the nearest tenth is approximately equal to the measure of angle C. Whoops, that's a very clumsy looking C. Okay, so I took the inverse cosine of this, and it gave me C, and I took the inverse cosine of this, gave me 65.4. Now I just hope that's right. 64.5. 64.5 is what it says. I wrote 65.4 because I'm a brain damaged old man. I promise that does say 64.5. So yay, got that one right. So what we're doing is we'll walk down memory lane. Got the ACTs coming up, so I thought I'd review the use of the law of cosines and the law of sines. We've done all this before. We rounded everything to the nearest tenth. Law of cosines, look for a missing side or a missing angle. Law of sines, I mean, in the law of cosines, missing side, missing angle. All right. You can do this.